Hello friends, the topic for today is numericals on diesel cycle. But before going through this particular lesson, you must follow lesson number 4 because it will give you a concept on diesel cycle, what diesel cycle is all about and what is the efficiency of diesel cycle and how to solve the numericals on diesel cycle under the course basics of IC engine. But before proceeding any further, I would like to introduce myself. My name is Harshit Agarwal, mechanical engineer, graduated from NIT Nagpur in 2008. I have cleared the Indian Engineering Services examination. I have got the offer letter from most of the Maharatna and Navratna companies. I have cleared the GATE examination as well. Regarding course fee, there is no course fee as such, but you can always contribute whatever you feel like. You can also follow me on the specified link. To start with the very first numerical, it says a diesel cycle has a compression ratio of 20. As I have already told you, what is the compression ratio? In this numerical, compression ratio is given as 20. And one more thing is given, cutoff volume is 5% of stroke volume. Keep in mind, it is cutoff volume, not cutoff ratio. Cutoff volume is given as 5% of stroke volume, and what we have to find? We have to find the air standard efficiency. So how we will proceed? We will simply write whatever is given in the question, and we will recall the efficiency formula for diesel cycle. The efficiency formula for diesel cycle was 1 minus r raised to power gamma minus 1 into 1 upon gamma into bracket Rc raised to power gamma minus 1 upon Rc minus 1. That was the formula for diesel cycle, in which Rc was the cutoff ratio and R is the compression ratio. Right. So R is given, which is 20, and condition, which is V3 minus V2 is equal to 0.05 into Vs. This is given. So the formula for efficiency we have right, and we have written V3 minus V2 is equal to 1.05 V1 minus V2. We have to find the cutoff ratio. That is why we are solving this. We are taking V2 common from left hand side as well as from right hand side, and we already know that V3 by V2 is Rc. So Rc minus 1 is equal to 0.05 R minus 1. What is R? R is the compression ratio, which is 20. So Rc minus 1 is equal to 0.05 into 19. So Rc is equal to 1.95. That is, cutoff ratio is 1.95. Simply put, 1.95 in Rc and 20 in R. So the final answer is the final equation becomes like this, and the answer is 64.9. Just go through this numerical. This is a bit easy numerical, and it has been asked several times in GATE and engineering services, right? And you will have a clear idea of how to manage between R, Rc and Re. In next problem we will see that the next problem is an engine working on diesel cycle, right, has a pressure and temperature of 1 bar and 17 degrees Celsius. P1 pressure is given as 1 bar and temperature is given as 17 degrees Celsius at the beginning of compression. At the start of compression, pressure is given as 1 bar and temperature is given as 17 degrees Celsius. Convert this 17 degrees Celsius into Kelvin. And the pressure at the end of compression is 35 bar. This is the end of 1 to 2 is reversible adiabatic compression. P1 is given as what? P1 is given as 1 bar, and at the end of compression it is given as 35 bar. That is, P2 is equal to P3 is given as 35 bar. One more thing is given is expansion ratio, which is 5. That means V4 by V3 is given as 5. So P1 is 1 bar, T1 is 290 Kelvin, P2 is 35 bar, and V4 by V3, that is expansion ratio, is 5. So what we have to find? We have to find three things in this particular numerical. That is, calculate heat addition, calculate heat rejection, and efficiency of the cycle. We have to find three things, that is efficiency of the cycle, heat addition and heat rejection, and data which is given in this problem is Cp, Cv and gamma. Right. So first of all we will find the compression ratio, that is the value of R. Similarly, P1 V1 is equal to P2 V2 raised to power gamma. P2 by P1 is equal to V1 by V2 raised to power gamma. We know that P2 by P1 is 35. So we have write the compression ratio as 12.67. We have written the compression ratio as 12.67, and the expansion ratio is given as 5. In my previous lesson I have told you compression ratio is equal to cutoff ratio into expansion ratio. We will find the Rc as well. Rc is R upon 5, which is 12.67 divided by 5. So the cutoff ratio is 2.534. So Rc we have calculated. R we have calculated. We will put these two things in this particular formula, which is 1 minus 1 upon R raised to power gamma minus 1 into 1 upon gamma bracket RC raised to power gamma minus 1 upon RC minus 1. The moment we will put these things in this formula, the final answer for efficiency is 54.88%. So the one thing we have already solved, which is the efficiency. Second thing is heat addition and heat rejection. How to calculate the heat addition and heat rejection. Keep your focus here. That is very important. Keep your focus here. Heat addition is from 2 to 3. So if we will get something like this, mcp constant pressure q is equal to mcp t3 minus t2, but we don't know t3 and t2. We will see how to find that. To calculate T3 and T2, we can write T2 by T1 is equal to P2 by P1. P2 by P1 is 35 raised to power gamma minus 1 upon gamma. So T2 by T1 is equal to 35 raised to power 1.4 minus 1 upon 1.4. So T2 is equal to 800 Kelvin. You got the T2 value of T2. Similarly, you have to find the value of T3. For 2 to 3, which is the constant pressure heat addition, V2 by V3 is equal to T2 by T3. And V2 by V3 is V3 by V2 is 2.53, which is cutoff ratio, which we have already calculated. So 1.1 upon 2.53 is equal to 800.8 upon T3. So the value of T3 is 2026.1758, which is the value of T3. And T2, I have already calculated. T2 is 800.86, T3 is 2026.175. So the value of heat addition is mcp T3 minus T2. M is 1, Cp is given in the question, and T3 minus T2. So the heat supplied is 1230.21. Heat supplied we have calculated. Efficiency we already know. The last thing which is left out is heat rejection. How to calculate the heat rejection? Efficiency is heat supplied minus heat rejection upon heat supplied. Efficiency which is already given is which is already we have calculated is 0.5488. Heat supplied is 1230.21, and heat rejection would be 555.06. So these are the three answer. Efficiency for diesel engine, you can write this also, because this is the general formula of efficiency, which is net work done upon heat supplied, which is QS minus QR upon QS. And direct formula of diesel cycle you have already known, right? So this is the two important numericals of diesel cycle. There are many of numericals. If you have any queries, if you want more numericals to be done, if you want more theory to be done, just write any problem, any issues in comment section. I'll be discussing with you all. I'll be replying to your comments. Thanks a lot from my side. This is Harshit Agarwal.